Hey, welcome back everybody to the second video for the work, power, and energy number 2 worksheet right there. Bang! Hopefully you've just watched the first video and you linked up and you switched over to this one. So if you haven't, I will throw the link for the first one. I'm going to try a new thing and throw it right in the beginning of the video or right there. So, right, somewhere there? No, is it over there? It's right there, right? It's behind me? There's a link behind me? All right, I guess it's right there. All right. So, hopefully you can link up there and hopefully it's gone by now. I don't know. I'll throw it at the end of the video too. Wow. So, we left off on number 6. I told you we are not going to do number 7. So let's start off with number 8. The first asteroid to be discovered is Sirius. It is the largest and most massive asteroid in our solar system. Our solar system's asteroid belt, having an estimated mass of 3 times 10 to the 21st kilograms. 3 times 10 to the 21st kilograms. And an orbital speed of 17,900 meters per second. All right. So determine the amount of kinetic energy it possesses. Kinetic energy equals 1/2 mv squared. This is a nice, simple plug and chug problem. We're just going to ease right into this second half of the problem set. 1/2 times the mass, 3 times 10 to the 21st, times V17900 squared. Make sure the only thing you are squaring is that 17,900. You do not square anything else. You square this first, then multiply, then multiply. In doing so, when we do this, we get the kinetic energy as equaling 4.81 times 10 to the 29th joules. Okay, 4.81 times 10 to the 29th joules. All right, excellent. Let's move on to number 9. All right, number 9 is a couple parts. So a bicycle has a kinetic energy of 124 joules. So the KE is 124 joules. What would the KE be if the bicycle had, okay, let's look at our equation. KE equals 1/2 mv squared. Part A, what happens if the bicycle had twice the mass and the same speed? So the mass was doubled. What would that do to our answer? If we double the mass, we double the kinetic energy. So we're just going to multiply it by 2 and it becomes 248. Remember, we had a problem similar to this in our last test, right? With momentum, changing the mass, changing the velocity, same thing here. All right, what happens if the mass stayed the same, but it was moving with twice the speed? So B, so 2 times the velocity, right? So it was moving at 2 times the speed. Now look at what happens with our velocity. It's squared. So if we double the velocity, right, 2v squared, what are we actually doing? We're going to distribute that. We're going to actually quadruple, or 4 times, right? Because 2 squared is 4. We're going to 4 times our answer. So we're going to do 4 times 124. And in doing so, that's going to be 496 joules. So we're going to quadruple our answer because it's squared. Right? For part C, what happens if we 1/2 the mass, but we moved at twice the speed? So if we saw up here, if we double the mass, we double our KE. So if we half the mass, we half our KE. So let's do that first. Divided by 2, that comes out to be, oh goodness, 62. And now if we doubled our velocity here, we saw that we quadruple it. So we're going to do the same thing here. Let's multiply that by 4. And multiplying that by 4 gives us 248 joules. Good job, guys. D, part D. The same mass was moving with half of the speed. Oh boy. Now we're moving it at half the speed. So instead of doing 2 velocity squared, we're going to do 1/2 the velocity squared, which means our 4 is now down at the bottom. So we're going to take velocity and divide it by 4. This 2 squared is 4. So now it's at the bottom. So we're going to take our original 124 and now divide it by 4. And doing this gives us 31 joules. All right. And then our last one, part E, not sure if you see that, part E. 3 times the mass was moving at 1/2 the speed. So we're going to multiply our original 124 times 3 because we're doing 3 times the mass. Right? When we did twice the mass, we multiplied by 2. Now we're going to multiply by 3. And then we're going to divide that by the 4 again, just like in the previous problem. And doing so, we get 93 joules. Don't worry, guys. I'm happy you made it through that, but you are not going to see that on a test or a quiz. I promise you, you're not going to see this, okay? But it's a good like mental math type deal, okay? It's good to help you strengthen how the equation works. But you won't see it on a test or a quiz. Yeah, Mr. F, woo. All right, a little shout out to my APES 2014 class. If you're out there, if you're watching it, hey, this one's for you. Got the wolf pack on the front, got the class on the back. So, all right. Now let's move on to question number 10. Oh boy, same type of problem. All right. Only this is dealing with GPE. So question number 10. We know that the GPE equals mgh. Thank goodness there's no squares or halves. We know that the mass is 78, 9.8, and the height is 870. So we know from this, oh, Annie's traveling. Okay, so let's multiply this out. Let me get my calculator. 78 times 9.8 times 870. So the original potential energy is 665,028 joules. Now it also gives a velocity, so let's just find the KE, 1/2 mv squared, 1/2 the mass, 78 times the velocity, 62 squared. Make sure you're only squaring the 62 first, okay? You need only square that 62 first. I apologize, you can't see that. And then we multiply by 78, and then we multiply by 1/2 or 0.5. And this gives us 149,916 joules. So we got our KE and our PE. Now for part A, we want to know what is the kinetic energy possessed. Oh, perfect. We did that. Part A, check. Look at that. We did it. We didn't even know we did it. B, what is the potential energy possessed by the skydiver? Whoa, we did B right there. We're on a roll, guys. C, what is the total mechanical energy? Okay, remember back from our very first notes video, we talked about mechanical energy as being both the kinetic and the potential combined. So for part C, what we're going to do is combine A and B. When we add these two up, 6, 6, 5, 0, 2, 8 plus 1, 4, 9, 9, 1, 6. We get the answer to C as being 814,944 joules. 814,944 joules. Easier than we thought. Yeah, sweet. All right, remember, mechanical energy is a combination of both potential and kinetic. All right. We're almost there, guys and gals. Number 11. How long would it take a 500-watt electric motor to do 1.5 times 10 to the 5th joules of work? So we have power as being 500 watts, and we have the work as being 1.5 times 10 to the 5th joules. And we want to know how long, time-wise. So let's take our power equation. Power equals work over time. 500 equals 1.5, just plugging everything in, over T. How do we solve this, guys? We multiply by T on both sides, and then we divide by the 500. So T times 500 equals 1.5 times 10 to the 5th. Now we divide by the 500 to get the T alone. And in doing this, 1.5 times 10 to the 5th divided by 500, we get 300 seconds. 300 seconds. All right. And then our final problem, number 12. Let's see. Number 12, how much work is exerted in the act of moving a 25 kilogram object 3 meters up a hill? So remember, work is equal to energy. So work is equal to FD, which is really equal to GPE, which is really equal to MGH. So work in this case is equal to MGH. If I haven't jammed this into your guys' head that work and energy are the same, I don't know what else we could do. Work and energy is the same. So we got 25 kilograms, 9.8, and it's being moved 3 meters up the hill. Multiplying all of this out, we get 735 joules of work. I want to give you all a round of applause. You guys did excellent today. So that is the entire sheet all done. All right. So please make sure you go over your answers. Please make sure if you have any questions, you email me. Okay, guys, email me. Fabianski, phsscience@gmail.com. And my last name, phsscience@gmail.com. It's the same as the YouTube title or whatever it is. So, all right. So any questions, please email me. We're thinking about having a little test or quiz coming up in the future, so make sure you're prepared on that. And I will see you guys all in the next video. The link for the first part of this video will be right behind me. Oh, wait. Now it's in front of me, isn't it? I swear, this thing moves around like crazy. Well, it's right there. So if you have any questions for the first part, make sure you go to there. And I will see you guys in the next video. All right. Take care, everybody. Mr. F saying, see ya.